Hello. Hello. Good afternoon, everyone. Let me try whether you can hear. Hello. Let me. Okay, let me find. Sorry, I just finished a tutorial. Let me find. Okay, so today I will just go through some, give you a overview about all the topic we cover so far. I will just highlight the something. Yeah. And then this Wednesday, I think I will just put a Zoom. So if you have any question you want to clarify, you can clarify during that section. Otherwise, you don't have to attend this Wednesday one. I also will not have any video record in this coming Wednesday. So if you don't have any question, it's okay. You don't have to attend it. But I will not record the video. What I want to show today. Maybe I will talk about this question first. Let me retrieve. I hope you all can hear me. Someone can hear, give a response. That one I will talk about it in a short while. Okay, I think you can hear, then I don't need to test. So okay, that one I will talk about it later. These two questions I will talk about it. I think this is the harder question in my assignment. I will talk a little bit more later. Let me talk about this question first. This is the interview question I found somewhere. So in this question, you are given two identical 8, and then you are allowed to throw them from level 1 to level 100, and then to find out which floor you will break. Then which floor you will break. Then you need to find out the exact floor. So the most naive approach, that means you won't get the job. If you answer that question in that way, that means that every from level 1 I start throw the 8. From level 1, level 2, level 3, level 4, level 5, level 6. I just keep try to level 100. Then see when the 8 break, then I found the answer. By doing that, then that mean that the worst case is I need to try 100 times. Yeah. So if you try every level, you need 100 times. 100 times. And this is really not a smart solution, because you're doing that. What does it imply? You only use 1/8, but why the question they trying to set, they give you two identical 8? Because definitely there are some trick you can use. So some people may be a little bit smart, then why not? I try the first one. I trying to throw from level 50. I from level 50, I just throw it. Then for the first 8, if the 8 break, then I will start trying from level 1 to level 49. If the 8 didn't break, then I from level 51 to 100. So yeah, this person a little bit smart. By doing that, that's in worst case you just need to try 50 times. Right. Can we do even better way? So yeah, by half can, yeah, actually if I further by half, that's mean I, the first one I try level 25. I try from level 25, level 50, level 75. If level 25 the 8 break, then I try level 1, 2, 3, 4, 5 to 25. If at level 25 I threw the first 8, they didn't break, then I can go to level 50 and then try the second time. And then if level 50 they didn't break, I can go to level 75. Whenever it break, definitely the answer is something between this to from here to here. Then the second 8, I just need to try 25 times. So roughly by doing that, in the worst case scenario, you reduce the to by 4, so it's about 25. Because if it's level 25, you throw the first one, it break, then you try level 1, level 2, level 3, level 4, level 5 to level 24, so 25 times. Worst case is 20. The answer is level 24. Or you try level 25, level 50, then you try. No, the worst case is more than 25. Because level 25, you try one times. Then level 50, you try second times. Level 75, you try third time. Level 100, you try. Level 100, you try 4 times. Then after that, from level 74, level 76, 77, 78, and so on and so forth, onward to 99. Yeah, so you try another 24 times. Am I right? 24 plus 4. So it's about 20. Anyway, it's about 24 plus 4, 28. So it's about 28 times. Yeah. Can we do it? Yeah, about 20, the worst case should be 28 times. Then in this scenario, can we do it even better? So I think you start finding that actually we can by half, by half, by half. Then why not I can further by half further by try to every 12 level or 13 level I try, so I can further reduce my interval. So if you keep doing this, of course you can reduce. Then you further reduce to another one is like by every 6 level. Then very soon you'll find that if your interval is too small, the first 8, the number of try will also increase. So what is the optimum approach? If you go and investigate about it, the optimum is from the interval. The interval is from 7 to 13. If your interval is from 7 to 13, the interval is every 7 level to 13 level. Yeah, they are the number of drop can, yeah, the maximum number of drop, required drop, the worst, in the worst case scenario is 19 times. But is it this is the best answer? Yeah. Actually, it's not. Yeah, this is just trying to fix the number. Your interval is fixed. The interval is fixed. The interval is fixed. So every time you try levels, every 7 level, every 7 level you try. Yeah. Yeah, it's a fixed interval, or every 13 level, 13 level, 13 level, you keep trying and trying for the first 8. Then whenever the 8 is break, then you try the interval, linearly try the throw the 8 from the previous throw +1 onward, +1 +1 +1 to just before the 8 break. So if you try this, yeah, you need, the worst case is 19 times. If the interval, the fixed interval is 7 floor to 13 floor, the number is 19. But can we make it even better? Yeah, as I said, even better way is make a variable interval. Variable interval means that first time I try from level, I think they suggest me is level 14. From level 14, then the next level I will try is 14 plus 13, which is 27, at level 27. Then the next one will be 27 plus 30 plus 12. Then 39, level 39. Then the next one is level 39 plus 11, which is 39 plus 11 is 50, level 50. Then the next one will be level 60, 50 plus 10. So I progressively, the interval is progressively decrease, reduce. Then you'll find that when you reach the last one is 99, then 100. Yeah, you progressively decrease. Then by doing that, then you will find that you will get the minimum number of drop to, I think the answer should be 14. Okay. Yeah. So that is like trying to tell you one thing is trying to tell you how they just share with you. Yeah, when they ask for interview, they may ask you this kind of a question. But how this thing actually related to dynamic programming problem. Actually, you find that actually you are repeatedly calculate. The thing is that you repeatedly calculate is like the interval, the repeated part is like the first 8 you throw, the interval, the gap between the before it break and at the level it break. Yeah, so that is the repeated overlapping part. So it's more generalized. It's like when it become a dynamic programming, of course this one is not dynamic, not really directly to dynamic programming. But if today I give you is the n floor, you have n floor and you have m8, identical 8. Yeah, that means these two are variable. The number of 8 and number of floor is a variable. Then this problem actually is a dynamic programming problem. And from this example, you can find out that your strategy, how your strategy, you need to varying is depend the number of floor and the number of 8 you have to decide how to decide the interval. So normally they interview you is like, first, if you cannot answer this first step, then or you answer the more silly one, tell them that you threw the app from level 1 to 100 and tell them 100 times you find out the answer. So definitely this group of people, you don't be surprised that you don't have second round interview. They don't need to interview you further. If you know how to divide by 2, then maybe you are a little bit better. But I would say nowadays, probably this is nothing special. If you know how to divide by 4, you don't know how to divide by 8, by more, to divide by 12, then yeah, I think all these people basically can forget about it. At least people need to be able to figure out is fixed interval. there's a range, which is level 7 to level 13, will give you the best range. Yeah, those are really outstanding. Person should be know that variable increase, progressively decrease the interval. Yeah, every try you decrease the interval will give you a even better result. That is a better, yeah, some so-called outstanding person, their interest to give you the second round interview lah. Yeah, and for those who are able to generalize the problem to M4, M8, and yeah, then that will be even better. So that you can think about it. Okay, so maybe I can answer the, let me see, the is the heavy light decomposed? I don't want to fix particular. That's why I think for I don't want to say particular solution definitely is the only solution. Okay, so that those I still let you open to think about it rather than I tell you that there's only one solution or must be use this particular solution. The fact is, if you always think in this way, like I said, you definitely, this is not the right way to solve the problem. It's not I tell you that there's particular, always you yourself should learn how to think, how to solve the problem. That's one thing. Another thing is like there's no, this kind of some problem, I would say there may not be only one solution, or my solution may not be the only solution. Yeah, so that's what I would like you to go and try. And for the city population problem, what I can point out is to you is first, okay, my test case, we have 4 test case. The first 2 test case, for sure you use, as long as you use any naive approach or very bad data structure, because the data size, the problem size, the number of city is only 10 to 50. So definitely you can easily solve that first 2 cases. If you not even can solve that first 2 cases, it's not you use the wrong algorithm, it's like you not even implement the things correctly. Okay, because that one I can see all the students can, so far I see everyone managed to solve that first 2 cases. They just use whatever adjacency list or adjacency metric, they definitely can solve it. That's not an issue. Recursive or non-recursive, whatever you name it, they definitely always can solve the first 2 test case, no problem one. And when you go to the third one and the fourth one, because they are 10 of 1,000 number of city, so the number of city is grow to 10 of 1,000. As I mentioned in the earlier lecture, if you use the adjacency metric, for sure just build that metric is already let you run out of time already. Yes, 80,000. The third case I can tell you directly, 80,000. The number of city is 80,000. So if you build the adjacency metric, you expect that the metric size is 80,000 by 80,000. 80,000 by 80,000. You know how many elements you need to fill in. And if you look at the question I have mentioned to you, is a tree. The particular network graph is a tree. There's no cycle. And the number of root is n-1. That means 80,000 city, you only have 79,999 edge. Yeah, but you build a 80,000 by 80,000 adjacency metric, just want to store the about 80,000 edge, is a bit waste your resource. the storage resource. So not surprising, a lot of people will run out of memory by doing that when you run the test case 3 and test case 4. So that definitely not a very smart way to do it. Then how to improve it, then that is what I would like you to think about it. Yeah. Like I said, if no one can or majority cannot think up any solution, at least you need to solve the first two. The first two, the small case, at least you need to be able to do it. Yeah, I will moderate. If no one can know how to do it, it's okay. Yeah, this is just for you to know, yeah, where you are only. So the purpose is just to let you know that there are something, yeah, there are a lot of things to learn in the future lah. So it don't need to worry so much. If you find that you don't know, your friend don't know, everyone don't know how to do it, it's okay. Later I also will moderate lah. I won't count that 2 cases. Yeah. So the purpose is for you to try and get the feel that when the problem size increase, and how important to have a good algorithm. When you have a bad algorithm, or when you have a bad data structure, yeah, you really will cost you a lot. That mainly, I think the thing I would like you to learn from this question. Yeah. So yeah, adjacency metric definitely will exist. The adjacency list, I think if I'm not too sure the fault cases, because I see someone managed to overcome it, but I haven't looked into the details. But I know that the third case probably cannot. Yeah. For adjacency, if you just blindly use the adjacency list, because I have mentioned that the number of edge is n-1 only. The number of city -1, which means that this particular graph is a very sparse graph. They are not even considered strongly connected. Not even strongly connected. Yeah. So far, I would say there are someone a few but not a lot so far. I didn't check this few days. Yeah, but I think there are very few people try, yeah, manage. But I won't because that 1 or 2 I will consider, yeah, must be quite large percentage. If not a lot, I will not count it. Don't worry. Then another one they ask about because another thing you need to be careful. Don't blindly and anyhow keep click. Your code is not working, then it's not working. Don't blindly keep click the submission, because the platform, they have some security. When you hit the maximum, they will really block your account. So I think there are some students encounter that. Yeah, that is not simply I reset your account. They really need to ask their I need to contact the administrator to purposely go and find out you, and then reset your account. So it will be very troublesome. Yeah, but I think if you normal use, you don't within very short period keep attacking the system, I think it should be fine. Otherwise, I also won't be able to help you. You let them trigger their alarm to block your account. That is very troublesome. Yeah. So for the next floor problem, okay, maybe I should go back to. So in the last Friday, we talked about this max floor problem. One of the, yeah, this thing is you need to take notes is like the advantage of this path searching. They can help you is like always they find a path. The path will help you to deselect the match and then select the new match. And then in my question is like you also need to I think it's like you have let me recall my problem. I think I instead of 2, I make it into 3 factor. Is project, mentor, and student. Okay, project mentor and student. So student must select the project, and then the project must assign to the mentor. Then the thing is like how you design your network is important before you run the matching. That is the hint I can tell you. Yeah, the network may not be just like that. It may not be just student, project, and mentor. Student to a project. So student only can select one project now. Then and then you cannot let, of course, I think not surprised that cannot be 2 students select the same project, or 1 project assigned to 2 mentor. You can try. If you don't do anything, you may encounter by doing this algorithm, when you have three uh 3 disjointed set, then you still run this algorithm, it may not be correct. So that means you need to do something additional in your network. I only can tell you the hint is in your network design. The graph may not be what you are thinking that directly. Well, you first, of course, you can just try that you introduce 3, and then you're trying to do the path searching by your own. Will it work? Will this Ford-Fulkerson algorithm always work? The residue graph, is it always can help you to find the maximum match for the student to the project to the mentor, or not? Is it always you can get? That means that they can help you when there's a wrong match, like what you see here. When you have three set, will it be able to really unselect and select another new one? That is something you need to think about it. Let me see whether I can come out a counter example. If I have this one to this one, first one will select, yeah, yes, this one immediately got problem. If you find one path, first one flow from here to here to here to here to here, right? Definitely later you definitely can find another path from here to here, then to here to here, right? Definitely got problem one. I believe that a lot of people very intuitive will do this, thinking that question set got 3. The one I give you definitely is not the right graph. You can directly blindly use it. If you can, I can immediately give you a counter example. If you try have 3 criteria, this one won't work. That means the project will be selected 2 times. Yeah, it's still a path. So you need to do something. You can't just blindly apply the Ford-Fulkerson. Like for this kind two set bipartite, when you have tripartite, maybe, yeah, when you have tripartite graph, then you probably cannot directly use them. You still can use it, just like your graph cannot be look like this. For the city test case 3, is it how we draw the graph or the way to find the path. I would say is your data structure. It's a data structure. You store the data structure, you store the graph. As I mentioned, that's why I keep emphasize that the graph, the number of nodes is only, the number of edge is only n-1. Because if you want to improve, you definitely can see that number of city is 80,000. Then the number of edge in this particular graph is only n-1. So, but if you use a very big data structure to store, then and somehow you and there's a unique path. That means there's no cycle. They won't have any cycle. So certain thing you can help you. I'm that actually I let you think about it. Okay, let me, I think I still got some slide discuss. Let me quickly give you an overview. So for second half, of course, I think in week 7 I have covered the okay. I need to give you a quick overview. In week 7, I have covered all the analysis of algorithm. So the time complexity, space complexity, best case, worst case, average case, the order of growth, how to represent order of growth in asymptotic notation, big O, big omega, big theta. All this you need to know. And then the efficiency classes, linear class, logarithmic class, constant class, to what else? Logarithmic, quadratic, linearamic, cubic, exponential, factorial. Yeah, all these are different efficient complexity classes. Yeah, which we commonly use for time complexity, space complexity. It may not be only all this. Sometimes maybe the number of solution, like n-queen problem, we don't know the order of growth of their number of solution. Yeah, sometimes we also use the asymptotic notation to represent the number of solution or anything. Yeah, so it's not limited to time complexity or space complexity. All this like you have learned about it based on the definition, the asymptotic. Where is the asymptotic notation? Asymptotic notation is just represent the order of growth. Yeah, so it's just a way to represent the order of growth. And it's like when you're not concerned so much about the exact function, then you just concerned about the order of growth. At that moment, you will use the asymptotic notation, big O, big omega, big theta, to represent the order of growth. Yeah. So don't assume that you only use it for time complexity. It may not be only used not only used in the time complexity or space complexity. So this is asymptotic notation. This concept you need to know. Yeah. And then in the week 8, we cover about the hashing. So it's a kind of a space-time trade-off. So it's like earlier you learned the linear search. Linear search is linear time, of course. Then after that, you try binary search tree or binary search you have learned earlier. All this will improve from linear times to logarithmic. So to further improve your search time, you want to search certain thing from the data set. Initially, you don't sort the data, then you only can try search all of them. Then that is kind of a sequential search. Then when you're trying to sort out in ascending order, descending order, in certain order, then you'll find that you probably can use binary search. to reduce your search time from linear to logarithmic. Then you want to further improve, then you will find that you need to sacrifice the space. So I need to use more space to store the data in a certain way, like a hash table. By doing that, then my search time can improve to constant time, because every time you give me the key, I just use the hash function, then to go to that particular, and then hash it to find out the corresponding index, and then I go to that particular location, the particular slot, retrieve the data. So in that kind of a hashing approach, I can improve to constant time. Yeah, so that is a hash table hashing. So we introduce cluster addressing and open addressing. Cluster addressing is just the address they refer, the cluster address is called refer to this location, this address, this particular index is fixed, because they just store the linked list behind. They store a linked list behind. So your data, if in the table, means that it definitely in this particular linked list. So it's a cluster addressing. Excuse me. For open addressing, that means you can change your slot. Why you can? Yeah, that means you store your data in the table itself. But if this particular slot is already occupied, you will use different probing approach. Different probing approach. Where's my picture? You will use different probing approach, maybe linear probing, maybe quadratic probing, maybe double hashing, to search, to find the alternate slot. And all this probing approach is ensure that you definitely will try out all the possible available, all the slot in the hash table. And also they try, this is one thing, and then they will try not to form the cluster. Linear probing definitely will form a primary cluster. Then quadratic probing will form a secondary cluster. Double hashing or double probing, they sort of the number of steps is decided by another hash function. So it's sort of every key have different number of steps to search the empty slot. Then it probably will be more random move compared to linear probing and quadratic probing. So forming a cluster chance is lower, because once you form the cluster, your search time for that particular table will close to linear. So that is what you don't reach. So that is those sort of issue in the open addressing. Yeah. So this is the hash table. After that, we introduce the graph. So graph itself is definitely is a big problem, very useful in mathematics to computer science. Is one of the big topic in mathematics and computer science, and you can solve a lot of problem in your daily life. In computer science, probably people working in computer network, in all, yeah, it's used a lot. And algorithm, definitely there are a lot of algorithm involved with the graph. And yeah, like you can see that all the project, all the assignment I show you, matching problem, it's a graph problem. And in your daily life, job scheduling, the job assignment to all these kind of a matching project assignment, all this, they need to do the matching, all this. Just one matching problem already have a lot of application in your daily life. Yeah. So path searching, all the path searching can help you to solve a lot of puzzle. So a lot of game, Sudoku or any maze, you can, yeah. Then to people working in robotic, the path searching, yeah, exploration, path the map exploration, yeah, all this, the strategy they can use, they need to use the graph to help them. So you need to know the graph. So it's formed by a set of a vertex and a set of an edge. So the degree of the vertex is the number of edge incident to it. Then when undirected graph, we said is connected if there is a path from any vertex to any other vertex. If a directed graph is said is a strongly connected if there is a path from any vertex to any other vertex. So these are the things I have mentioned. A graph is a cyclic, that means it contains one or more cycle. Otherwise, it is acyclic. That is what the assignment the problem you have is an acyclic graph, or sometimes they may call it as a tree. So a complete graph on n vertex is a simple undirected graph that contains exactly one edge between each pair of a distinct vertex. That means all the connections are fully connected. How, like again, so this kind of a graph, if you use the adjacency metric, you'll find that okay, because nearly all the edges, all the element you is one instead of zero. But when you have a very sparse connected, just like what the assignment you have, the problem, you find that if you really go and look at the metric itself, 90% in the metric, 90% element are zero all the time. And every time you need to scan and check those zero, of course they are not connected, but you still need to check the whole row, all are zero. Only one or two very few edges are connected. Of course, it's very time consuming by doing that, especially when your problem size increase. So yeah, that is the adjacency metric and adjacency list for this given graph. For undirected graph, you will get two times of the edges, because they will assume A connect to B, B also connect to A. So that's why you can see 3 to 7 and then 7 to 3. Okay, think about it. So after we introduce the graph, in the following week we introduce, of course you have a graph, or just like you have a tree. One of the very typical problem you need to know is how to visit every node in the graph systematically. So we introduce two algorithms, breadth first search and depth first search. Yeah, these are two very classic. Of course, there are a lot of traversal algorithm which we will introduce to you in the future in the next level. Yeah, for this module, we just introduced two. I would say it's the simplest one, breadth first search and depth first search. So one is the level by level traversal. So breadth first search is kind of a level order. So you always visit the nearest one, followed by 1, 2, then followed by 4, 3, 6, 9, 4, 3, 6, 5, and so on and so forth. But one of the key is like whether breadth first search or depth first search, I need to indicate where is the starting vertex. Yeah, because algorithm itself didn't indicate. So we need to provide you. And also when you encounter the unvisited nodes, we need, definitely there are more than one. So the order, which is the next one, you need to visit first. The way you travel, the order is ascending order, descending order, alphabetical order, or reverse alphabetical order, or any order. Based on breadth first search or depth first search, they are not right or wrong. But if we want to have a consistent output, then we need to divide them. But sometimes may not necessary, is depend on the problem. For example, breadth first search can provide me the shorter path between two vertex, from the starting vertex to any other vertex. The shorter path may not be unique, but the shorter distance in any order, you definitely give me the same number, the same distance. So if my question is ask you the shorter distance, actually I don't need to tell you the order, the visiting order, because whether you use ascending or descending, or you use whatever, as long as you use the breadth first search, you definitely will give me the same answer. So in that case, you not be surprised, question wouldn't tell you the visiting order, because you use any order, you will get the same answer. So that is some characteristic you need to know about breadth first search and depth first search. Yeah, so of course, breadth-first search, you need to use a queue, which is very similar to the data structure you learn the binary tree when you do the level order traversal in the binary tree. Yeah, you also use a queue. You find that algorithm is very similar. For depth-first search, I think last week the lab we already introduced. They basically is a kind of a greedy strategy. They're trying to visit as far, whenever they encounter unvisited nodes, they will just visit it, yeah, as far as he can. Then when he move to certain place, there's no more unvisited nodes, then they will do the backtracking. And then they backward, and then trying to travel another one. So such a traversal strategy, you will find that you need to use a stack. In fact, this algorithm, and you compare to the breadth-first search, you just change a queue to a stack. The rest almost exactly the same, but the result will be totally look very different. One is breadth-first search, one become a depth-first search. But the stack or queue is kind of a storage to assist you to remember what is the next nodes to visit. So these are the things. Then from here we learn about there's a something that you push the vertex and then you pop. Then people learn that in our daily life a lot of things is like you do something, then you carry on, you repeat the same procedure. When you can't do something further, then you start reverse back the earlier decision. And then that kind of behavior is known as backtracking. And you can use the backtracking to do a lot of things. We introduce you make a decision, you're trying to, if you can do the same thing again, you carry on. When you reach certain point, you can't do it, or it's not the result you want, you backtrack and then try another path. That is what you will find that a lot of problem you can use this approach to resolve. I think let me move. Okay. Okay, then you found it. Then like we introduced the coloring, the map coloring, and we also introduce you the add queen problem. I think this week tutorial we also introduce another one to print out all the permutation. In short, all this is same thing. I would say you will find that there are some common thing, as I mentioned in the earlier lecture. You will find that they always trying to run a for loop. Yeah, it's just like this one and add queen problem have some constraint. Actually, if there's no constraint, that means it's like you color something and then you move on to the next step, repeat the same procedure. When you reach certain point, you find that you cannot do, then they uncolor. They reverse. The same thing earlier you color before the recursive call, then now you uncolor it back. That means this step is wrong. I need to try alternate one. Then you keep run this for loop and try different combination. Yeah, until you try out all of them. So you will use the same thing for the tutorial, this week tutorial, the question 2. I ask you to print out permutation. In our daily life, yeah, some problem you want to try all the permutation. How you can try all the how you ensure that you have tried out all the permutation. Yeah, so you can use the backtracking to systematically try out all the permutation, all the combination. Yeah, so you will find that this one have a for loop, then you do something, recursive call, undo something. You'll find that add queen problem also similar. You run a for loop, then you check whether you can place a queen. If you place a queen, you carry on this recursive, move on to the next column. And then if you cannot, you find that this particular arrangement is not correct. In the halfway, once you found it's not correct, it's not safe, then you return false. Then I will start trying to delete the queen and then try alternate path, because I run a for loop here to try out all the possible position along the column. Yeah, so you find that very similar. The 8 queen color mate, a lot of these kind of a backtracking algorithm, the algorithm fundamental are similar. Just the problem every time the story is slightly different only. It's whether you can identify the pattern or not before you implement. Yeah, if you just trying to memorize, I can tell you this kind of a question, there are a lot of similar problem. You won't be able to memorize all of them. But after you look at these few examples, you should realize that actually there's a pattern one. They always need to run a for loop. They always have a recursive function to try the smaller sub-problem in the following sub-problem. And then every time is either you do something and then you undo something. You place a queen, you delete a queen. Earlier one, you color it, then you uncolor it. Backtracking. So that is the backtracking. Then we also introduced last Monday, I think. Yeah, we introduced the dynamic programming. Yeah, so we introduced the top-down approach and bottom-up approach. One of the important concept in the dynamic programming is like you find that the problem you divide and conquer, but when you divide into several sub-problem, and you will find that certain sub-problem are repeated, are exactly the same, and not necessary for you to repeatedly calculate so many times. If you repeatedly calculate them, it definitely cost you a lot. So to reduce the cost to computational times, then the best way probably is just you calculate once and then find a place to remember it. Then next time you encounter the similar problem, then you just retrieve the result from the earlier table or something like that. So that is like dynamic programming. As I mentioned, this word programming here is filling the table, not really a coding. So that's why this is a concept of memorization. Yeah, it's not only memorize the things, they're also trying to like recursively, when you encounter the exactly the same problem, same sub problem, then you can use the store optimum solution to directly to the problem, the sub problem you encounter again. Yeah. So yeah, we introduced Fibonacci is one very direct. Yeah. Then we also introduced the road cutting and 0-1 net set problem, and a lot. I think this week I also in the tutorial I introduced another one, to find the longer substring, which their first half sum is equal to the second half sum. Doesn't give you a number of digit, a few digit string. Then the substring, in this string there's a substring. The first half is the sum of the first half digit is equal to the second half. Yeah. Then we want to find the longest one. Yeah, that is the one we discuss in this week tutorial. You can go and think about it. Then the last topic is the matching problem. Okay. Is the hidden test case solvable? You may need to use something. Yeah. I said that the test case 3 and 4 is just give you a challenge to think about it. Yeah. Like I said, if you just try, don't limit yourself to just want to use the method. Yeah, you may need to think something additional by your own. As I mentioned that the network actually is not that complex. It's a tree, and you only have n-1 edge. So if I mentioned just now a few times already, the adjacency metric definitely not working. Adjacency list also may not be that good. Yeah, you may need to do something further. That I let you try to think about it. Let me see anything. So I think that's all for today. So this Wednesday, later I will put a Zoom link in the NTU Learn. So this Wednesday, if you have any question want to clarify, you can use that Zoom meeting to clarify your doubt. Otherwise, yeah, I think I already give you all the lecture is here. So you can spend more time to think about the assignment to practice. Then you also don't have to worry so much about the test won't be that difficult as your assignment. Of course, I have mentioned few times already. Yeah. The lab test will be in week 14, Thursday. Okay? If no other question, I will end this lecture. Thank you. Well, everything. Remember the lab test and the final quiz. The final quiz is cover everything from week 1 all the way to week 13. It's everything. All the concept is not limited to the time complexity or limited to my part or what. It's everything. From the part 1, from the week 1, whatever you learn, it can be anything, any concept. We can test you. Yeah. We only have 13 weeks. I don't have magic can extend further. So you just take notes. Yeah. So take notes. The lab test will be everything. The lab test. Yeah, for the programming test, I can test you any data structure. Of course, I can test you any data structure. Just like you ask you to write the breadth first search or depth first search, even that one you also need to use a stack or queue. You don't know the first half, definitely you can't do anything. So that's not surprising. Then I want to store something in a linked list. Of course, I can test you with the linked list. I can't you can't limit me. You want to solve a problem, you always need some data structure together with the algorithm together. It cannot be separate them. Must we be able to declare? So for I don't know which one you refer to. If you're talking about the assignment, you find that the last assignment, one of the question I make it everything editable again. So you can edit them. So must we be able? I think to take this module, that's why I worry that end up actually you only know how to call the function, you don't know how to declare the function. That is not right. So make sure you also know how to declare the any data structure. You're also able to write the function by your own. Not every time only know how to call the function. For the lab test, I was only can say that the question will be designed for you to be able to complete in half an hour. Yeah. Do you need any extra function? Can I declare another additional variable or data structure or whatever? You can do it. I will let you do it. But as long as you don't trying to declare something, is just want to cheat the my main function or something, whatever form. Yeah, you declare certain function is just for your own use to make your code easy to read for your own purpose. Yeah, that is fine. You're supposed to be able. I think at reach this stage is I need to expect you not only know how to call the function, you need to be able to declare the function by your own also. Okay? How many questions are there? I think I haven't decided. I'm thinking maybe need to go to four programming question. Either 3 to 4. Because I'm worried 3 question is a bit risky. That if you all 3 questions you don't know, then the result will be very bad. Maybe I will go to 4 question. Yeah, I will let you know. I will let you know this Wednesday. I'll make an announcement. Yeah, the concept can be from everything. You don't limit to, I only test you the time complexity. It can be anything, the concept. Of course, as I mentioned that it's an MCQ, so definitely test you is the concept. The time will be similar to the previous test one. Yeah, just the venue, I need to check with the lab which place are available. So I need to arrange with them this week. So I will let you know later. But you expect that the time schedule will be similar to the last one. The times will be similar. Just the venue may not be the same place. Okay? If no other question, that is today's lecture. Okay? Thank you.